Hey everyone, I'm Priyansha and welcome back to my YouTube channel. Today we will be solving the code daily challenge, which is delete nodes from linked list present in array. So let's see what is this question and how we can solve it. So in this question, you are given an array of integers, nums, and the head of a linked list, okay? And we need to return the head of the modified linked list after removing all the nodes from the linked list that have a value that exists in nums. Okay, so let's see this question. So in this question, you have been given with an array nums and the head of a linked list, and you need to return the head of the modified linked list such that it doesn't contains the value of this nums. Okay, so in this case, this one exists in this nums, this 2 exists in this nums, this 3 exists in this nums, 4 and 5 doesn't exist, so its answer will be 4 5. So this is the head of the modified linked list. So in this question, you need to remove all the nodes which contains value which are present in the nums. Okay, so let's see how we can solve it. So first of all, we need to find in that whether that value exists in nums or not. Okay, it is an array, and how we can look for any value in the array? By just iterating, right? So if the size of the linked list is this and we will check for every node, then it will become of n square, or I can say n into m complexity, right? So let's see the constraints. So nums dot length is 10 ki power 5, and where we have number of nodes in the given list can also go up to 10 ki power 5. So it will become a complexity of 10 ki power 10. Okay, so one thing is that we can go to every node and we can look for that node in the nums list by iterating it. Okay, but it will not satisfy our time constraints. Okay, so how we can look for the node value in this array? So we can simply store all those values in an unordered set, or we can say unordered map. Hash map will also work, right? So we can simply store all these values. Let me just correct its spelling, otherwise you guys will say that, yeah. So we can just simply store its values in an unordered set or unordered map, anything will work. And because the complexity of searching in an unordered set is over 1, so yeah, we can store all these values first in an unordered set to find whether this value exists in the set or not. Okay, now the point is how we will delete the node from the linked list. Okay, so let's see, initially our head is at this, and we will check whether that value exists in the nums or not. If yes, then there are two cases. That node might be an head node, or that node might be an middle node, right? So let's see the first case, have head node. Okay, so in this case, one is an head node whose value exists in the unordered set. So in the case of head node, what we just need to do is we just simply do head is equals to head ka next, right? And we will simply be able to delete its head node, because now our head is pointing to this, and now head does not have any track of this node. Simply this node will get deleted. Now again our head is pointing to 2 whose value exists in this set, so again head will become head ka next, and again this head don't have any more track of this node. Again 3 is in head node now, and its value exists in this set. Now again head will become head ka next. Now again 3 will be deleted. Now 4 and 5 doesn't exist in this node, in this set. It means we have got our modified linked list. Now this is the first case, when in this case all the nodes are the head nodes whose value matches with the values of our unordered set. Okay, so let's see another case. If our node is in middle node, then how we will delete that node? Now in this case, nums is 1 and our linked list is 1 2 1 2 1 2. Okay, Let's see. Now initially our head is pointing to this node. Yeah, this is an also head node. So what we will do in this case? Simply head will become head ka next, and this node will get deleted. Okay. Now head is pointing to this, right? Now its value doesn't exist in this node. So okay, now we can't move the head. If we will move the head, then we will lose track of our head node. So we will create a current whose value is initially as head. Now current is pointing to head initially. Okay, now we will start checking with this current pointer. We will not move the head pointer anymore. If we will move it, then we will lose track of our head node. Okay, now does the value of current exist in nums? No. So what we will do is simply we will move our current to current ka next, right? Okay, now our current is pointing to this node. But see, here now one exists in this nums, but how we will change the pointer if we haven't kept any track of the previous node? Because by deleting the node, what means the previous node next should not point to this, and instead it should point to this. Now automatically this node will get deleted. But what if we haven't kept the track of this node? So initially we have to create two pointers, previous and current, which are pointing to the head. Okay, now let's see again by moving the pointer current. Okay, so initially both our pointers are pointing to head. Okay, so now if that value doesn't matches the nums, then what we will do is we will simply put the previous current node in the previous and simply move the current pointer to the current ka next if our value doesn't matches, right? So in this case current is 2, so previous will point to 2 now, and our current will become current ka next. Okay, now 1 exists in this, so now how we will delete it? So this is our previous, this is our current, and we need to delete this pointer, change this pointer to this pointer. Okay, so what we can do is we can just simply say we need to change the pointer of previous ka next or right, and what we need to put in this pointer is current ka next. This is our current node and this is our current ka next, so we need to put current ka next in the previous ka next. Okay, now the case is how we will change previous and current. Current will become, see, now we need to check for this node, right? So this node will surely become current, but earlier the previous node of this is this, but now this node is deleted, so the previous node of this will become this, right? So previous is already pointing to this node, so we will not change the previous pointer in the case of deletion, and we will change only the current pointer. Okay, now what will be the value of current pointer? See, what is current pointer? Previous ka next, right? So previous ka next, right? So see, it becomes so simple. So whenever value exists in the set, then we will follow these steps. Whenever value doesn't exist in the set, then we will follow these steps. For the middle nodes and for the head node, initially we will increment the pointer by this, head becomes head ka next. That's all two cases can be here in this question. So let's see how we can code it so that you can have a more better idea. So initially, first of all, we need to store its size, and then we need to create an unordered set, right, of integer st, and we will simply iterate in the nums and we'll simply insert all the elements in this set, right? Okay, now what we need to do is we need to increment the head pointer if head is pointing to the, if the value of the head exists in the set, while st dot contains head ka value, right? So what we will do is we will just simply do head becomes head ka next. Now our head node is pointing to the node which we need to return, and we need to delete the middle nodes now. So first of all we need to keep the track of current and previous. We will also initialize previous with head, no worries. So now while current, why we have not reached to the end of the linked list. So what we will check, if set contains current ka value, if yes, then what we need to do is we need to follow these things. Previous next is equals to current next. We are changing the pointer previous next. It means our node is deleted, and now our current node will point to previous ka next. Else what we need to do is we will just change our previous will become current, and current will become current ka next, right? And by the end of this loop we will simply return our head node. So let's try run this. Yeah, it's working fine. Let's try submitting it. So yeah, it's working fine. Now let's talk about its time and space complexity. So see, we have created this one for loop for iterating this nums vector, and we are iterating this linked list as well, right? So its overall time complexity will become big O of n plus m, n for the nums and m for the list, I would say. And as we have created an unordered set for storing all the values or all the n values, so its space complexity will become big O of n. So yeah, that's all for this video. I hope you have got some good idea for solving this question. If you still have any doubts, you can post in the comment section. I will surely try to answer them. Bye guys, see you in the next video. Till then, keep learning and stay curious.